Hello everyone, this video is about trigonometry past paper questions. Number 1, the diagram shows a triangle ABC, AB, the angle 90 degrees, perpendicular. We basically just look at the diagram. By expressing BD in terms of theta, show that 20 sine squared equals 9 cos BD. Okay, so first of all, look at the big triangle, the triangle ABC. If you look at the triangle ABC, if this is theta, this is 90 minus theta. So now we know that this is 90 minus theta. Look at the triangle ABD now, ABD. This is 90 minus theta. Of course, this angle is then theta. So look at this triangle again, ABD. This is theta, this is 9. Tangent theta is opposite over adjacent, so 9 over BD. We can find BD in terms of theta. BD equals 9 over tangent theta. And look at the triangle on the right now. From the triangle on the right here, the BDC triangle, we have 20 cm and the angle is theta, and therefore BD, using sine, we get sine theta equals opposite over hypotenuse, BD over 20, so BD is 20 sine theta. We have BD equals this, BD equals that, so this equals that, and 9 over means 9 divided by, tangent is sine over cos, keep change flip, we multiply both sides by sine, we get 9 cos equals 20 sine squared, which is what we need to prove. And showing all necessary working, calculate theta. So we start with the 20 sine squared equals 9 cos. The answer to part 1. Sine squared is 1 minus cos squared. 20 times 1, 20 times cos squared. And we get, move everything to the right. Minus becomes plus, plus becomes minus. We have a quadratic. This is just like 20a squared plus 9a minus 20. We have the a, the b, and the c. Use the quadratic formula. We get the value of a, either this or this. This is rejected, you'll get an error. The cos cannot be smaller than minus 1. From here we get the value of cos theta, and the theta is therefore inverse cos. We get the answer in degrees. Alright, that's it for number 1. Now let's do a different kind of question. This one, prove the identity. So 1 minus cos, 1 over cos minus tangent all squared is the same as 1 over cos minus sine over cos, because tangent is sine over cos. So over cos, common denominator, we can combine the fraction 1 minus sine over cos. We square, we get 1 minus sine all squared divided by cos squared, which is 1 minus sine squared. Using the difference of two squares, the denominator becomes a plus b, a minus b, difference of two squares. And from the numerator, we still have 1 minus sine times 1 minus sine, cancel out 1 minus sine, we get 1 minus sine over 1 plus sine, which is what we need to prove. Part 2. This is exactly the same as the left hand side, but be careful with the angle. This is x, this is 2x, so it's 2x, not x. So the left hand side is the same as the right hand side, but we use 2x. Of course, we can cross multiply, 3 times this, 1 times this. We can expand, move everything with sign 2x to the right. We have 1 plus 3, which is 4. We move this 1 to the left. 3 minus 1 is 2. We divide by 4. 2 divided by 4 is 1/2. And the base angle is inverse sine 1/2, which is pi over 3. and look at the domain from 0 to pi, but this is for x. The angle we are dealing with is 2x multiplied throughout by 2 from 0 to 2 pi. So this means we can use all 4 quadrants, and since the sign value is positive 1/2, this means we are only using the first quadrant and the second quadrant. So 2x equals, in the first quadrant, pi over 6. In the second quadrant, pi minus pi over 6, or 180 minus alpha, so we get 5 pi over 6. But this is 2x. The x is divided by 2, we get this final answer. And yeah, last kind of question, the yeah, let's do this one. The function is such that f of x equals a plus b cos f pi over 3 equals 5, f of pi equals 11. So f of pi over 3 means we replace the x with pi over 3. Cos pi over 3 is cos 60 degrees 1/2. So we multiply throughout by 2, we get 2a plus b equals 10. And from f of pi equals 11, we replace the x with 11, and we get cos pi, which is minus 1. So we have a minus b equals 11. Rewrite down here, add to cancel out the b. 2 plus 1 is 3, 10 plus 11 is 21, the a is 7. If we have the a, we can use this equation to find the b. The a is 7, the b is minus 4. And for part 2, find the set of values of k for which the equation f of x equals k has no solution. So cos x is between minus 1 and 1. If we multiply by minus 4, we get minus 1 times minus 4, 1 times minus 4. Because we are multiplying by negative, we have to change the sign. And we add 7, add 7, add 7. We get the f of x is between 3 and 11. We just flip the 3, 11 here. And now f of x is between 3 and 11. So if we want f of x equals k has no solution, then the k must be smaller than 3 or bigger than 11. Alright, that's it. I'll see you again next time.